Now for our last two examples in this world of three variables and three equations. And the first two examples that we did, we came up with nice answers. Nice in the sense that we had values for x, values for y, and values for z. In these next two examples, we're going to encounter different situations, which we've seen before in the world of 2x2s, where either there is no solution or infinitely many solutions. Looking at this problem here, when I take a look at it, and I've labeled them now again, A, B, and C, when I look at A and C, I notice that we have positive 4 and negative 4. So I'm thinking, let's use A and C, 3x plus 4y plus 5z equals 8, and then 2x minus 4y plus 6z equals 8. And we can eliminate the y variables. So we have 5x plus 11z equals 16. So we've eliminated y. Going back here, we've used A and C. I'm going to use A and B this time. So looking at A, we have 3x plus 4y plus 5z equals 8. And then B is x minus 2y plus 3z equals, whoops, that's very messy, negative 6. We have to eliminate y. So looking, we have negative 2y, positive 4y. I'm going to multiply this equation here by 2 to get 2x minus 4y plus 6z equals negative 12. This equation here doesn't have to be touched. And now, when we combine, y's are eliminated, and we have 5x plus 11z equals to negative 4. So now we have two equations over here and over here. And we need to work with these two to eliminate more variables. So 5x plus 11z equals 16, and 5x plus 11z is equal to negative 4. Now, some of you might be noticing here saying, wait a second, something isn't right here. We're taking x and z's. We don't know what they are, but we're doing the same thing to x and z in both of these equations. We're multiplying x by 5, x by 5. So far, it's the same, whatever we choose for x. Then we're taking this z. Again, we don't know, but we're doing the same math to it. We're multiplying by 11 and multiplying by 11. So far, in this side of the equation, the information is the same. However, when we come to this side of the equation, we have two different answers, 16 and negative 4. So if some of you are saying, this doesn't make sense. If we're multiplying the x's by 5s and the 11 by 7 and we're adding them, it should give us the same answer. And you're right, it should. So this is an instance where we're not going to have any solution. But let's continue with the process we've been working with and prove there's no solution. So here, it doesn't matter. We can see both coefficients are the same, so we're going to end up eliminating both. So let's say we're going to multiply this top one by negative 1. Negative 5x minus 11z is equal to negative 16. We don't have to do anything with the second equation. 5x plus 11z is equal to negative 4. And now look what happens here. Both these variables are gone. They've been eliminated. So on this side of the equation, remember, we still have an equation here. On this side of the equation, there's nothing left standing. So it is a 0. However, on this side of the equation, we do have information. We have negative 16 minus 4, so we have negative 20 on this side of the equation. Look at this equation here. 0 equals negative 20. That's not true. Not true. So when you eliminate variables, if it ends up you've eliminated all your variables, there are no variables left standing, so one side of your equation is 0. If the other side of the equation is a number, you're left with a false statement. So this situation, when you have mathematical lie that you're looking at, says that there is no solution here, which is what we saw when we were looking here. So to say no solution, there's two ways you can do it. One is this 0 with the slash through it. That says no solution or empty set. And another way is using set notation with brackets that are empty.